Good day, everyone. My name is Stephanie Midgley, and I'm with the Department of Agriculture in the Western Cape Province. Today, I'm going to present on the modeling and mapping the future climatic conditions for pome and stone fruit production in the Western Cape of South Africa. Before I begin, I'd like to acknowledge my co-workers, Professor Roland Schulze and Nick Davis, both in KwaZulu-Natal. Horticultural science has identified climate change, decreasing water availability and quality, and increases in extreme weather conditions as three of the biggest risks to the pome and stone fruit industries in South Africa. Many studies have now shown, through observed trend analysis, that warming, shifting rainfall patterns, and more extreme weather are already occurring. The climate change projections so far generally show rapid warming and changing patterns of rainfall. This means that long-term adaptation planning is now essential for perennial fruit crops, particularly considering their economic lifetime of 20 to 30 years or longer. The research objective for this study was to model and map the changes in key climatic parameters and risks of importance to pome and stone fruit production in the Western Cape and the Langkloof. The outputs are a science-based, relevant and practical guide for pome and stone fruit farmers in South Africa on climate change risks, impacts, and adaptation responses. These have been published in 2 volumes and also an executive summary, and they are available from Horticultural Science. Horticultural Science is also currently developing an online app which will show the full complement of maps that are available. The study area is the Western Cape, but we have also included the Langkloof and including the eastern part of the Langkloof, which extends into the Eastern Cape Province. We mapped 11 stone and pome fruit production regions, as shown in the colored areas on this map. And we also did some high-resolution mapping for these areas, but in this presentation I will show the main mapping results for the province as a whole. The spatial resolution for the study was quinary catchments, or we also just call them quinaries. They are relatively homogeneous agricultural and hydrological spatial units regarding climate, topography, and soils across the country. In the Western Cape Province, we have just over 1,400 such quinaries. The existing historical climate databases included rainfall, temperature, and temperature derivatives. They are for the period 1950 to 1999, and this provides the reference or the baseline against which the projected impacts of climate change were evaluated. Professor Schulze and his co-workers have developed this 50-year quality-controlled historical time series of daily maximum and minimum temperature at any unmeasured location in the study area at a spatial resolution of 1 arc minute of latitude-longitude, or in other words, roughly 1.7 by 1.7 kilometers. Thereafter, representative grid points were determined for each of the quinaries using techniques developed by Professor Schulze. The resulting 50-year series of daily maximum and minimum temperatures for each quinary was then used to generate daily estimates of solar radiation. We used 2 sets of global circulation models for the climate change modeling. The first one was what's called the CMIP3 ensemble of GCMs. These were used in the IPCC's 4th assessment report. They were statistically downscaled to over 2,000 climate stations in South Africa and then further bias corrected for the quinary catchments. The models listed there, the 5 models, were used in this study together with the future scenario A2 of the 4th assessment. Daily values of rainfall, maximum and minimum temperatures, and computed daily values of solar radiation, maximum and minimum relative humidity, and reference potential evaporation were then generated for 2 20-year time periods. The first was the present, ending in 1990, and the second was the intermediate future, spanning the time frame just around the middle of the century, about 2046 to 2065. The second set of GCMs is a group of 10 models They are what's called the Cordex Ensemble, or CMIP5, and these were used in the IPCC 5th assessment report. They were also statistically downscaled and bias corrected. I've listed the 10 there. Also, the same procedure was followed to generate, in this case, a 30-year time periods, and we used 2 periods, the historical, which ended in 2005, and the immediate future, which runs to around 2045. It's important to note that all the maps that we show for the predicted future and also for the change from the present to the future are means or medians of around 4 or 5 different GCMs. We do not show only one model, except in the case of red coloring, where we have thus far only used one model. So the variance between the models is not shown, but they are always the median or mean of a set or an ensemble of models. The modeled variables are all based on temperature or derivatives thereof. The focus was firstly on the loss of winter chilling, in other words, the warming occurring in the winter period, and secondly, the impact of high temperature stress on fruit production, which is generally associated with summer growing season. We are going to show in this presentation 5 of these variables. The first one is accumulated chill units. For this, we use the infratech chill model, which gives us positive chill units, or PCUs. And we did it in 2 ways. We modeled both the seasonal accumulated PCUs between April and August, and then we also modeled the month by which certain thresholds of accumulated PCUs are reached. And we did this for 250, 500, and 700 PCUs. Then we looked at high temperatures, and we used 2 ways of depicting this. The first is the mean daily maximum temperature in January. The second is the number of days annually where temperatures are above 35 degrees Celsius. And then we turned to sunburn risk for apples. And this was modeled based on science field research that has been done in the Western Cape on apples. And we modeled this as the number of days monthly in the summer months where fruit surface temperature is equal to or above 48 degrees Celsius, and the daily maximum temperature is between 34 and 38.9 degrees Celsius. The next one is red color development of apples, and this is also based on empirical research that's been done in the Western Cape on apples and the thresholds that are required for color development. So the first requirement is at least 1 day of a daily minimum temperature of less than 12 degrees Celsius, so a cool night, and this is needed for the induction of anthocyanin synthesis. This must be followed by 3 consecutive days, at least, of a daytime temperature of 20 to 28 degrees Celsius, which is optimal for strong synthesis of anthocyanin. But all of this is also conditional on light being available, and so we looked at solar radiation on the qualifying days being at least 60% of those days maximum solar radiation potential. The last one we're going to show is reference potential evaporation. We used the Penman-Monteith method here, and the values were converted to an APAN equivalent. This is the first set of maps showing accumulated seasonal chill units from April to August. The left-hand map shows the historical situation and the right-hand map the future. If we look at the historical map, we see that all those areas in green, so from light green all the way to very dark green, those are areas with relatively high seasonal chill units. Those are where most of our production regions are currently, especially for pome fruit. And you can see the dark green areas showing the colder production areas of the Bokkerveld. Generally, pome fruit regions historically have had about 800 to 2,000 PCUs, the higher end being in the Bokkerveld. And the stone fruit regions have had a little bit less than that, so between 600 and 800 PCUs or above. Then in the future, we see that because of warming, we're seeing reductions of between 250 and 500 PCUs. And specifically for the pome fruit regions, we now seem to end up with between 200 and 1,600 PCUs, with 200 obviously being really, really low for pome fruit, in fact too low. 1,600 would be what's left in those green areas. In the Bokkerveld areas that are currently cold will remain relatively cold, and probably have enough twill units for pome fruit production in future. The stone fruit regions, we will see areas having between 200 and 600 PCUs, which is also of concern to stone fruit. The next set of maps shows the months by which the twill unit thresholds are achieved. The top set of maps shows 500 PCUs, with the left-hand map always showing the historical, the right-hand map the future, and then the bottom set of maps is for 700 PCUs. If we just focus on 500 PCUs, we see that historically, those colors that are shown in yellow, those are the colder areas, the high-lying mountainous areas of the Bokkerveld and also into the Karoo. There we find that 500 PCUs are largely achieved by May or June, and then the light orange areas going into darker orange, that is when the 500 PCUs are achieved in July, and that's mainly in the warmer production regions. The intermediate future, if we look at the right-hand map, so roughly middle of the century, we see that there's very little yellow left, so most of those colder areas, we achieve 500 PCUs in either June or in July, which is still fine. But we see that many of the southern areas, so Elgin-Grabouw, Verliesdorp, we're going into the greens and blues, which means that in those warmer areas, 500 PCUs will only be achieved in August or September. If we look at 700 PCUs, in the bottom left map, we see that most areas, those are reached in the colder regions in June or July, and in the warmer southern areas, also mainly in July, in some areas only in August. But generally still achieving those units in most of the production areas for pome fruit. In the future, if we look at the bottom right-hand map, we see that the cooler production areas are now achieving 700 PCUs by July, which is probably still fine, especially if we use rest-breaking agents, as the warmer areas currently do. That should still be fine. But the warmer areas, the coastal areas, are going into purple, and that means that those areas will only receive 700 PCUs by September or October, or not at all. In areas that go white, it means that they are not achieved at all. So the higher twill cultivars will become unviable in many of those southern production regions. The next variable we looked at was high temperature stress. These maps show the mean daily maximum temperature in January, with the left-hand map showing the historical situation. And the yellows, you can see the southern coastal regions, obviously a little bit cooler. And then we see the darker reds and orange and dark purple really showing us areas where we have much warmer January temperatures going up the west coast particularly, and also in the Little Karoo. So the high values, those dark reds, we usually see in the intermontane areas, and those are especially areas where stone fruit are currently grown. We're talking about routine temperatures of above 30 degrees Celsius in summer, but most of the high-lying and coastal fruit areas we see generally temperatures of lower than 28 degrees Celsius in January. If we go into the future, the right-hand map shows the change from the historical to the future. And the blues show us that the change is a little bit lower, so a lower rate of warming of maximum temperature. And so in the cooler areas of Elgin-Grabouw, for example, we would see lower than 2 degrees there. But we see that the highest increases are in the interior regions, those dark reds and oranges, and also the Langkloof coming out quite strongly in strong red colors. That is of concern for the Langkloof farmers. And then we see the high-lying western interior, the Bokkerveld, somewhere between 2.3 and 2.6 degrees warming of January maximum temperatures. Another way of looking at high temperature stress is the number of days annually above 35 degrees Celsius. The left-hand map is generally showing yellows, which means that there are fewer than 20 such days annually at the moment at those temperatures. We do see up the west coast some of the orange there, the Olifantsriver Valley, so areas where there is a bit of stone fruit production, we do see that some of those areas get much hotter, up to 40 days above 35 degrees Celsius per year. If we go to the future, the right-hand side shows the change, and we see that areas where there's dark orange and red means that there's a substantial increase in number of days, so between 20 and 40 additional days at these temperatures, especially up the west coast, the Olifantsriver Valley, parts of the Little Karoo. And in other areas, it's generally fewer than 20 additional days, but that is could still be quite significant. All right, the next set of maps shows the sunburn risk, and I'm going to show it for both January, the top set, and March, which is the bottom set. I've included March because historically farmers have not really been that concerned about sunburn at the end of the season in autumn when things have been cooler, and generally the sunburn does not occur on those late apples at that time, but more and more farmers have been saying that they are now seeing sunburn in the late season, and so we map that as well. In January and in fact in March as well, we see that the risk of sunburn, particularly up the west coast in the those reds shown there, and also in the Little Karoo, there are areas where there's a higher sunburn risk. We do get sunburn in Elgin-Grabo as well, but it doesn't come out that strongly in this mapping. And then if the center shows the future, where we see a lot more red in those same areas, and then we see the change maps on the right-hand side. Let me just focus on those oranges and reds, particularly once again in the lower Berg River system, so Wellington, north of Wellington, going up into other parts of the Witzenberg, the warmer areas of the Witzenberg, and also the Olifants River Valley, parts of the Breda Valley, and also quite large parts of the Little Karoo. We see a number of additional days of sunburn risk, so 4 or 5 additional days in January of sunburn risk. And then in March, we do see an increase in sunburn risk in some of the areas that I mentioned, for example, in the Bokkerveld, Tulbagh area. Those areas have picked up in the last few years increased sunburn in March. That's already happening. Then we also looked at red color development. As I said, I'm only going to show the maps for combined March and April. This is the number of days that are conducive to red color development, and the left-hand map shows the historical, with the reds showing a high number of days that are conducive. So the coastal areas receiving historically 18 to 30 such days in March and April. In the Langkloof, it's about 24 to 30 days, and in the high-lying interior of the Bokkerveld, it's been generally above 21 days, but in some areas, especially the Ko-Bokkerveld, more than 30 such days. So very, very good conditions for red apples. In the intermediate future, the middle map, we see much of that red disappearing, which means that the coastal areas end up with only 3 to 9 such days. The Langkloof ends up with only 6 to 12 such days. And the high-lying interior has quite a relatively big drop as well, and ends up with 9 to 15 such days. And the change is shown on the right-hand side, and the relative change being high in the areas that are currently cooler. So a lot of loss of such days, but there will still be days conducive to red color development, and it will just be a question of also using cultivars that are resilient to the temperature sensitivity in this regard. Right, the last one I'm going to show is the reference potential evaporation. The left-hand map shows that generally across most of the fruit regions, we have about 1,200 to 1,900 millimeters reference potential evaporation. And then in the right-hand map, we see the change where the darker reds show the higher increases. Generally across all the fruit regions, it's between 70 and 120 millimeters additional reference potential evaporation. And the larger increases, so those more than 100 millimeters, are seen in Elgin, most of the northwestern high-lying regions, the eastern Langkloof, Koe-Montague region, Calitzdorp in the Little Karoo, and most of the Stellenbosch-Berg area, and also the upper Breda region. So those are areas where we could see an increased demand for irrigation, for example, from such strong increases. So finally, just in wrapping up, the impacts of the warming that we're expecting from climate change, so roughly 2 degrees Celsius by the mid-century, and associated changes are very area specific. In all the production regions, rising evapotranspiration will increase the irrigation demand, and so water resources availability and the efficient use of irrigation strategies will become very critical. If we just focus on the pome fruit production regions, we see that the southwestern coastal production regions, so Elgin, Grabo, Faber, Verliesdorp, and also Greyton and other areas in that area, are the greatest risk owing to losses in winter chill. But we do think that these areas will become more suited then to stone fruit. The northwestern high-lying regions of the Koa and Warmbokkenveld and also the Langkloof probably will remain suited to perm fruit production from a winter chill perspective, but growers will have to adapt to high temperature risks in summer. So, for example, better sunburn protection for the crop. In all regions, the loss of days in autumn that are conducive to red color development of apples will require a greater use of high coloring cultivars and mutants. Then for stone fruit production, the warmer parts of the Klein Karoo, the Little Karoo, could become more marginal. There are some areas there that show very strong warming that are already quite warm. Cultivars with a higher winter chill requirement will, over time, need to be phased out. The northern parts of the Berg River region is projected to become much warmer and possibly drier than at present. And so farmers will have to look very carefully at their choice of cultivars, and climatically suitable stone fruit cultivar choices will become even more important as part of adaptation. In conclusion, in this study we have provided an initial lens of what the climate could look like in the region, what it would mean for deciduous fruit farmers, and we hope to, by showing these maps, just to raise awareness, stimulate discussion, and also stimulate the consideration of appropriate responses, which need to be spatially explicit, they need to be contextualized and crop specific, because we see that conditions and future projections look very different across the province and across the different production regions. So the different regions are affected differently, and opportunities therefore do exist for continued pome and stone fruit production with adaptation, and this could possibly include some shifts, spatial shifts. It will include shifts in cultivars, but there will be opportunities because of the diversity of climatic situations into the future as well, to make adjustments. So we recommend further research on alternative production regions outside the Western Cape and the Langkloof. There may be other areas in South Africa which become more suited to pome and stone fruit production. And we also need more research on cost-effective adaptation approaches and technologies, and to make those available to farmers. Finally, we also recommend that future studies explore how the new set of IPCC scenarios and the downscale GCMs could be used to project the future climate, and whether these would make a big difference to the outcomes and the messages. I've included references here that are included in the slides for those who want to follow up on those. There are 2 pages of references, just the key ones. Thank you very much for your attention, and I'm very happy to take questions. People can email me and ask me questions about the presentation or other aspects of this topic. Thank you.